Let's go ahead and get started on this. There's a starter question there. It's kind of a summary of what we talked about yesterday, being able to identify what conic section you're working with. These get a little bit complicated, but you can make them easier if you know exactly what you're looking for. So if you can look at the equation and tell, oh, this is what this graph is going to turn into, then you're in better shape. So let's review this. If the equation has one squared variable, then what do we know for a fact it's got to be? Got to be a parabola. Okay, got to be a parabola. Okay, if it has two squared variables, then we've got three different choices. It's either a hyperbola, an ellipse, or a circle, and let's talk about how we can tell. If it has the same sign and the same coefficients, so they are exactly the same number in front, both positive, both negative, exact same number, what is it? Circle. Then it's a circle. Okay, same signs, so they're either both negative or both positive, but they are different numbers, different size for the x and different size for the y. Then it's an ellipse. Okay, and if they're different signs, doesn't matter if they are the same number, as long as they're different signs, what is it? Then it's a hyperbola. Now, just a reminder, in order to use these quick rules right here, normally these are written with the variables on the same side. So get all the variables on one side, that's when these rules apply. If you had variables on different sides, they could be the same sign on different signs, but when you put them on the same side, then they'd be different. So make sure you put them all on the same side. We call that standard form, general form, as long as they're all on the same side. And then if we put it in that nice graph-friendly form, then it's what we call standard form. Okay, so let's talk about the definition of an ellipse, where the ellipse comes from. So we talked about circle and parabola yesterday. Circle is a set of points that are equidistant from a given point. So the given point is the center, and that distance is the radius. Then we talked about the definition for a parabola. A parabola is a set of points that are equidistant from a given point and a given line. And the given point is called a focus, and the given line is called the directrix. Okay, when we're talking about the definition for an ellipse, we only have 2 points. Okay, so it says an ellipse is the set of points on a plane, the sum of whose distances from 2 fixed points is constant. And those 2 fixed points are called, you can call them focuses. Okay, usually you'll see them called foci. Okay, you can call them foci, I suppose. Usually they're called foci. Yeah, Focky would, I probably would not do that. Okay, probably wouldn't. Foci is very common, foci. So anyway, so if we take a look at a quick demonstration of how this works, I've pulled up, this is a little GIF that I found on the internet. You'll notice that, so it takes a second to look at what's going on here. And a lot of times I'll bring in a piece of string, and I'll have 2 people hold it on the board, and then we'll take a marker and we'll just kind of stretch the string and go around. That you can make an ellipse that way, but you can see the same thing happen here. Imagine somebody holding a piece of string right here and the other end right here, and then taking a marker and then just kind of stretching it and going around like this. You'll notice this blue length right here gets shorter when the red one gets longer, and vice versa. And you can notice that the total length of this string is 10 units, and you can see the blue one getting longer when the red one gets shorter, and so forth. So that's how an ellipse is formed. You've got the sum of the distances. So the distance from this focus to a point on the ellipse is the blue line, and the red line is the distance from this focus to the point on the ellipse. And that sum has to be the same all the time. Okay? The sum of whose distances from those given points is always constant. It's always exactly the same. That's why you see these numbers changing, but that 10 never changes. That string is always exactly the same length. Does that make sense? Okay. So let's go back here. And remember, we know that from those previous sections when we talked about if we've got 2 squared variables, they have the same sign, but they have different coefficients. Okay? Get rid of that. Okay, and the graph-friendly form for an ellipse has perfect squares, just like the graph-friendly form for a parabola has perfect squares, and the graph-friendly form for a circle has perfect squares. So you might guess that just like we had to do some completing of the square with circles and with parabolas, we're going to have to do the same type of thing there. We do have a little bit of vocabulary to learn on an ellipse. So we've got a center for an ellipse. We've got two foci, two vertices, okay? We've got something called a major axis and a minor axis, and this isn't all the vocabulary, okay? But if we get it in a nice graph-friendly form, it's easy to pick off all of these things. And this is why it's helpful to know, if you look at the equation, exactly what type of graph you're going to make, because then you know, oh, I need to figure out what the length of the latus rectum is if it's a parabola. I need to figure out what the length of the major axis is if it's an ellipse and stuff like that, okay? So this is an ellipse in graph-friendly form. If you wanted to look at how to derive the equation for these, you can look it up on the internet. Your textbook is over there. I suppose you could look in there before you leave. But it's very similar to what we did yesterday with parabolas. Okay? It involves the distance formula and stuff like that. Okay? So this is a graph-friendly form for an ellipse. On this one, it has a center at 0, 0. Okay? So we usually start with that key point on kind of the center of the whole thing being at the origin, okay? And when we graph something like this, you'll notice I've got an example right here. We go a units in the x direction. So I want you to notice that underneath the x squared is an a squared. Whatever that number is underneath the x squared is an a squared. Okay, so we're going to go that far in the x direction, and we're going to go b units in the y direction. So whatever the number is underneath the y squared, that's how far you're going to go in that direction. So let's go ahead and start graphing this. So the center is at 0, 0. That's not part of the ellipse, that's just where it's located. And in the x direction, I'm going to go the square root of this number right here. So find the x, take the square root of the number underneath the x, and we're going to go 1, 2, 3, 4, 5 units from the center in that direction, and 5 units from the center in that direction. Okay? We do the same thing in the vertical direction. Find the y, look underneath it, take the square root of that. So we're going to go 3 units in the y direction. So from the center, 1, 2, 3, we're going to go up here. 1, 2, 3, we're going to go down here. Now, you don't have to do this, but I find this kind of helpful in the long run. When we're graphing something like this, I like putting a little box around this, okay, just a little dotted, not a whole bunch of dots, okay. When you're drawing these, it's hard to make these not look kind of funky, okay. If I do these on the board, I'm pretty good at them, but on a piece of paper or like this, it's kind of hard for me. So what I do is I take this, and then I use the box to kind of help guide the way I draw this. So this is kind of a stretched out ellipse, okay. Not too bad. Mine looks a little bit like a lopsided potato, but we'll go with it. Okay? So that solid red curve that I just drew there, that is the ellipse. Now the center is very helpful, but it's not part of the ellipse. And we're going to find the foci in just a second. They're not part of the ellipse. They are part of the definition, and they're very useful. Okay? So the major axis is determined by whichever is bigger out of A and B. And we're going to say bigger in quotes. Okay, mathematically we'd be talking about greater and that sort of thing. Okay, this is important. The foci are always located on the major axis, So the major axis is the longer of the two. So the long axis runs horizontal on this one. Okay. The minor axis is the other one. It's the shorter of the two. Okay. So the foci are going to be right along this axis right here. Now, I've got this little question right here because the other day I said foci are always where on a conic section? They are always inside the curved part of the conic section. Foci are always inside the curved part of the conic section. So you can see this curves around here, this curves around here. So the foci have to be inside the ellipse. They can't be outside the ellipse because it curves inward. Does that make sense? Okay. The foci are C units from the center on the major axis. So the center is going to be important for a couple of reasons. It's how we find these 4 points that we use to sketch this, okay? And it's also the location from which we start to find the foci. So we need to figure out what C is. And here's the formula for C. It's a squared minus b squared equals c squared. A squared minus b squared equals c squared. Now that looks a heck of a lot like the Pythagorean theorem, okay? It's actually derived from the Pythagorean theorem. We could look at where this comes up and stuff like that. I'd just like you to remember that it's a squared minus b squared equals c squared. And remember, a is going to be the big one. B is going to be the small one of these numbers right here, okay? And the way I want you to think of it this way is this is kind of like the Pythagorean theorem, but the Pythagorean theorem, if we added them together, that would make them bigger than, that would make C bigger than either A, which is right here, or B, which is right here. And the reason we need to subtract is so that we can have the foci inside the curved part. It's got to be inside this box that we just made there. Does that make sense? So if this is 5 and this is 3, I've got to subtract something from 5 in order to be inside along that major axis. Does that work? Okay, keep that in mind, because I think if you think about these this way, it's going to make a heck of a lot more sense when we start doing hyperbolas tomorrow. Okay, hyperbolas are a little bit more complicated. Okay, so it's the big one squared minus the little one squared. So in this case, it's going to be 5 squared minus 3 squared. Or we've got the number sitting right there. So we've got 25 minus 9 equals c squared. So that's c squared equals 16. So c is 4. So that means we're going to go 4 units to the left and to the right. So I go right here and I go right here. So I've got a focus point right here and a focus point right here. Okay? Any questions? Okay, now we actually have, call it 7 points that we'd want to label on something like this. I've got these 2 points right here, the ends of the the minor axis. I've got these points right here, the end of the major axis. I've got the 2 foci, and then I've got the center. So I'd want to label each one of those, okay? Now, these points right here, a lot of times those are called the vertices. The end points of the major axis, those are called the vertices. Okay, so I'm going to blow this up just a little bit so I've got room to write. So this is 0, 0. This one is 4, 0. This one is 5, 0. This one is negative 4, 0. And this one's negative 5, 0. And then this point right here, we went up 3. So that would be 0, 3. And we went down 3 here. This would be 0, negative 3. That right there would be a complete graph. We've got everything we need there. Okay? Any questions? Sure? Okay, let's do this one toward the bottom. What's going to be different about this? Okay, it's not centered at the origin. And remember the other day I cautioned you and I said, please make sure you're careful. Before you find h and k, find the x. The number with that is going to be the k. Find the y. The number with that is going to be the h, and then the number with the y is going to be the k. So we take the opposite of this number right here. It's going to be centered at 1. Opposite of this number right here, negative 1 for the y. So I'm going to go over 1 and down 1. So there's the center. Okay, now look at the number underneath the x squared term. So we're going to look underneath here. It's a 9. In the x direction, I'm going to take the square root of that, and that's how far I'm going to go. So how far am I going to go to the left and the right? I'm going to go 3 units. So 1, 2, 3, put a point right here. 1, 2, 3, put a point right there. Now, because that's the smaller of the two, that's going to be the minor axis. And then look underneath the y, take the square root, that's a 5. So we're going to go 5 units in the y direction. So I'm going to go up 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. So we're about right there. Okay. Again, you don't have to do this. Okay. I like doing it because I think in the long run it makes for a better looking graph. It also will help you once we start graphing hyperbolas. Okay. So I've got a vertex here and I've got a vertex here. I've got an endpoint of a minor axis right there and there. So I can go ahead and draw this. Okay, so it kind of goes around. It's kind of flat to start with, and then it kind of hugs along that line. Looks something like this. It's not too shabby. Okay, and again, the major axis is whichever one is longer. So the major axis runs up and down, so how long is it on this particular one? We went up 5 and down 5, so it would be 2 times 5, so that's going to be 10. And how long is the minor axis? It's going to be 6 units long, okay? And the major axis in this particular one runs vertically. Major axis runs vertically, up and down. That would be our major axis, our longer axis, and our minor axis runs the other direction, okay? Foci is C units from the center on the major axis. It's the big one minus the little one. So again, it's going to be 25 minus 9 equals C squared. So that means C equals 4. So that means I'm going to go up 4 and I'm going to go down 4. And there are the foci. Any questions? And then we just go through and we label everything. So this is 1, negative 1. This is 1, oops. One, negative 1. This is over 1, and we went up 4 from here, so that would be 1, 3. This would be 1, 4. This is 1. We went down 4 from there, so that's going to be negative 5. And this is 1, negative 6. And then we just have these other 2 points of endpoints of the minor axis. So this is going to be, let's see, we went down 1, so the y-coordinate's going to be negative 1. And we went forward 3, so that's going to be 4 for this one right here, and minus 2 for that one right there. Any questions about how to graph that and label it? Easier or harder than a parabola? Yeah, a little bit easier, okay, in my opinion. Okay, any questions? Okay, at the bottom of the page there, it talks about a couple of vocabulary words that you're going to see. We could talk about something called the semi-major and the semi-minor axis. So what do you think the semi-major and the semi-minor axis are, Noah?
I'm guessing the semi-major axis is between the foci and the foci.
Could be. Let me ask you this. What's a semicircle?
Half.
Half a circle. So semi-major is half the major axis, semi-minor is half the minor axis. It's a fancy way of saying, in this case, how far is it from there to there, from the center to a vertex? It's asking us what's A, okay? And on this one, what's B, okay? Does that make sense? Okay. If you wanted to look at somebody else's explanation, look something up on the internet. If you wanted to look in your textbook before you leave or something like that, I've found that this is the best way to think of an ellipse. Because in the long run, it's much easier to graph an ellipse and a hyperbola back to back. The hard thing about these, and you'll see this when you take a test on this in 1050, is it's pretty easy to figure these out until you put them all together on a test. Okay, and then you've got to remember all these little details about each one. And if you think about how to do an ellipse this way, then a hyperbola is very, very similar. There are a couple minor changes about it. And it's a lot easier to make those changes if you're thinking about an ellipse this way. So let's just run through and graph a couple of these. A few of these are kind of interesting just because of the numbers that are chosen. On this previous page, on each one of these graphs, we never had any ugly numbers to deal with. Everything worked out perfectly. It is very hard to make. The examples that I've given there, those are some of the very few ellipses where all the numbers work out really nice. Most of the time you're going to end up with a radical sooner or later. So let's take a look at this one right here. Again, look at the variable that we've got here and here. There's no adding or subtracting, so we haven't moved this. So the center is at the origin. Underneath the y, so in the y direction, how far are we going to go? We're going to go 4. So I'm going to go up 4 and I'm going to go down 4. In the x direction, only 3. So still some pretty nice points to do. Go ahead and try and graph this without doing the rectangle. I would recommend doing the rectangle at least on some of them. This isn't very stretched out, not very elongated or anything, okay? So, but this is still the major axis. It has a vertical major axis because the larger number was underneath the y, okay? Now, labeling these 5 points, piece of cake. How do you find the C? How do you find how far we run along the major axis from the center to get to the foci? What's that little phrase? Big one minus little one. Big one is 16, little one is 9. So if I do 16 minus 9, I get 7, and that's got to be C squared. So what's C? C is radical 7. Okay? So that means I'm going to go up radical 7. Radical 7 is somewhere in between 2 and 3. So I'm going to put a focus right there. And I'm going to put a point right there. So if this is 0, 0, this would be 0, comma radical 7, and this would be 0, comma negative radical 7. Okay, and then I'll label these other two just for the heck of it. This was 0, 4, and this was 0, negative 4. Any questions there? Easy enough? Okay. Which way is the major axis going to run on this one, horizontal or vertical? Horizontal. It's going to be longer in the x direction than it is in the y direction. We're going to go 5 in each of the x directions and only 2 in the y direction. So we're going to have a really elongated, really squished, boy, that's ugly. Okay? What's C?
0, 0. No. I was in the center.
Right. Yep, big one minus little one, so it's going to be the square root of 21. So it's going to be in between 4 and 5. So that puts the foci way out here. You got a vertex here and a vertex here and a center right there. This is really stretched out. So the further apart you get the foci, the more elongated, the more squished the ellipse is. Okay? Okay, do I need to label all those points? You can label them, right? Okay, let's take a look at the next one. Again, what's the difference here? The center. Write down what H and K is, please. Okay, now before we have any verbal embarrassment here, please remember, you have to find the variable and then pick the number. H is always with X. Y is always with K. All right? And these are going to be in a different order than most of the ones that we've come across because we're not dealing with functions, we're dealing with relations. So, where is the center of this ellipse? Okay, it is -1, 2. Okay, I can't tell you how many times on a test I put a problem like this and somebody will look at this and say, oh, I know where this is. This is at 2, -1. Okay? Not right, because you can't just go through and pick the first one and put it there and the second one and put it there. You want to find what variable it's with. Okay? That's what impacts which direction it goes based on that number. Okay, everybody good? Okay, do I need to graph this one? Okay, what's that one going to look like? It's going to look kind of like this one, but not exactly. How's it going to look? Okay, it's going to have a horizontal major axis rather than a vertical major axis. But the other features are going to be the same. We're going to have a radical of 7 along the major axis and all that sort of stuff. In fact, let me go ahead and show this because this is kind of interesting. You'll notice how these numbers worked out, how this x coordinate was always the same. It was always 0. And then it was just plus and minus radical 7 and plus and minus 4. Let's take a look at what happens when we do this one over here. So the center is at -1, 2. So we're right here. And then in the y direction, I'm going to go, let's see, this is kind of ugly. Radical 7 up, so that's a little bit more than 2. So we're about right here. And radical 7 down. And then we're going to go 4 units in this direction. So there and there. So that's what it looks like. Center is negative 1, 2. This point right here, let's see, I went forward 4 units, so that's going to be 3, 2. And I went back 4 units, so that's going to be negative 5, 2. And I went up radical 7. So it's still negative 1 for an x-coordinate, but this is going to be 2 plus radical 7. And the easiest way to write this one, rather than actually figuring it out and subtracting it out on your calculator, would be negative 1 for the x-coordinate, because you went back. And then you went down another radical 7. So this would be 2 minus radical 7. So you'll notice that there's some symmetry there. And then this is kind of cool. 16 minus 7 is 9. So what's C? What's the distance from the center to the focus? 3. Okay, so if I go forward 3, that's going to be 2, 2. And if I go back 3, that's going to be negative 4, 2. So this is very typical. Most of the time you're going to end up with a radical in there somewhere. Okay? Any questions? Okay, let's take a look at these last couple. We got a few more to take a look at, and then I've got a few from your assignment that we can look at. What's wrong with this? It's not in the correct form. How would you get it in the correct form? Okay, Brandon's not going to. Yeah, you have to have a 1 over here. You have to have a perfect square with x and y, and this has to be a 1 for it to be in graph-friendly form. Now that doesn't mean this is an ellipse. It's got 2 squared variables. They're on the same side and they have the same sign and they're different numbers. This is going to be an ellipse. But in order to get it in that form, we've got to go through and we've got to make that a 1. So I'm going to divide both sides by 8. That leaves me with y squared over 2 plus x squared over 8. And then on that side I have a 1. I'm going to blow this up again so I've got some more room. Good thing is the center's at 0, 0. In the y direction, how far are we going to go? We're going to go radical 2. Okay? Now, I think we can do this. Let's do this. Let's call that 1 and that negative 1 and that 2. Whoops. That 2. Let's change the scale a little bit. Thanks. So I need to go up the square root of 2. So that's going to be about 1.4. So I'm going to be right there. That would be 0, radical 2. I'm going to go down radical 2. So that's going to be 0, negative radical 2. Then I need to go radical 8. Radical 8 is a little bit less than 3, so that's going to be somewhere around here, and maybe about right here. I went forward radical 8, so I'm going to write down that vertex as 2 radical 2, 0, and this one is negative 2 radical 2, 0. So I'm going to connect these guys right here. We got a lot of red floating around on this graph. That really looks like a potato. Looks like it's got eyes on it and all sorts of stuff. Okay. And the distance from the center to the focus. Radical. How do you find it using these two numbers? Big one minus little one. 8 minus 2 is 6. So I'm going to go forward radical 6, which is a little bit more than 2. So I'm going to put that about right here. So I've got a focus there, and I've got a focus there. So this is going to be radical 6, 0, and this one is negative radical 6, 0. And of course, the center is at 0, 0. Okay, so we got all those points floating around there, tons of radicals on this problem. But even as ugly as the numbers are, it's still pretty easy, isn't it? Okay. The only thing that I'd say people struggle with when they have a problem like this is knowing roughly where to put this. If you need to put this into your calculator to get a decimal approximation for it, like this is going to be about 2.8. If you need to throw that in a calculator and figure out what it is, no problem at all. Okay, any questions? Okay, that one already had a perfect square and a perfect square with x and a perfect square with y. This one does not. So on this one, we're going to have to complete the squares. So this gets a little bit interesting because Yesterday we did some completing the square, but they were very easy because the leading coefficient was 1. So let's talk about how we do this. Okay? So the first thing I'm going to do is I'm going to collect all the x's and y's together. So we want to do this in a very careful way. 4x squared plus 8x, save room to complete the square, plus 3y squared minus 6y, save room to complete the square, and then we've got that 5 over there. Now, can I just start completing the square on this? I can't. I can't. I've got to have that coefficient be a 1. And the hard part about this is, when you were dealing with parabolas, and we did this before, like 5 or 6 months ago, you could just go through and you could divide both sides. That doesn't work on these. Okay? So in order to do this, we're going to factor out the 4. So we're going to have an x squared plus 2x, close the parentheses, saving room to complete the square. I'm going to factor out a 3. That's a y squared minus 2y, save room to complete the square, and then over on this side I get a 5. So you'll notice that everything written up there in black was in the problem to begin with. I haven't changed anything, I've just rearranged it. Now complete the square. Half the middle coefficient, that's a positive 1. Square that and put it right here. Now, if you'll remember what I talked to you about several months ago when we did this, I said whenever you put this on here and there's a coefficient out front, draw a little line right here. If you draw that little line, it's a visual reminder that, hey, I put a 1 inside the parentheses, but there's a 4 outside the parentheses. So effectively, what have I actually done to that side? Okay, I've actually added 4. Effectively, I added 4. I'm going to compensate for that on the other side by adding 4 there also. If I added 4 pounds over to this side of the balance scale, I'm going to add 4 pounds on the other side of the balance scale. Same thing here, except for that's a negative 1. That's a plus 1. Again, when you put that, draw that little line. We effectively added 3. So here's what we've got. Here's the equation we're going to graph. Or at least close to it. Let's see, and add all those up, we get 12. Can we graph it yet? You can tell where the center is, but you can't quite graph it yet because we need that to be a 1. So we're going to go through and we're going to divide every term by 12. So here's what I've got. X plus 1, quantity squared over 3. Y minus 1, quantity squared over 4 equals 1. Centers at negative 1, 1. We're going to go the square root of 3 in the x direction. We're going to go the square root of, we're going to go 2 in the y direction. And what's c going to be on this problem? As ugly as the rest of this was, it's just going to be a 1. It's the square root of 4 minus 3, so it's going to be a 1. Okay? So we are at 1, negative 1, 1. Square root of 3 in the x direction, that's about 1.7. 2 in the y direction. My screen is a little bit distorted. Mine looks like a really ugly circle on my screen, but that shows the correct stretch right there. It is a vertical major axis, and I just go up 1 and down 1. Focus, center, focus, vertex, vertex there. And then you could label everything, right? Any questions? Sure? Okay. So let's run through and do this really quickly. It says find the equation of the ellipse given the following information. Does it say graph the whole thing? It doesn't. Remember yesterday I said make sure you pay attention to the instructions and do exactly what it says. All we have to do is come up with the equation. So let's do this. Centers at 0, 0. That's good because that tells you what h and k is. It has a focus at 0, 2. So 0, 2, we go up here. I've got a focus right there. I've got a center right here. I'm going to blow this up so we get a little more room. And then I've got vertices at 0, plus and minus 3. So I've got a vertex up here and I've got a vertex down there. Now, if they told me I've got a focus here, wouldn't I also have to have a focus there even if they didn't tell me that? Okay. So let's stop and think about this. Okay, now some teachers and some textbooks will say you have to write the major variable first. So on this one, the major axis runs in the y direction, so they might say you have to write the y first. Okay, I don't really care. Okay, it's standard to write that first, but it doesn't really matter. So I'm going to write x squared, y squared, and a 1 over here. If you've got an ellipse centered at the origin, that's what it looks like. So if this were a test question, you ought to at least be able to get that far. Which of these two numbers can you figure out just by looking at this right here? The one underneath the y. It would be the a squared, not that it matters. It's the bigger one squared. From here to here, it's 3 units, right? If that's 3, this has got to be a 9. Now, stop and think for just a second. Don't say anything out loud. We have to find this number right here. I know what a is. I know the big one is 3. And I square that, I get a squared is 9. This number underneath here, we'd normally call that b squared, because that's the smaller one. So how do I find c? How do I find b if I don't know? We know c. So a on this one is 3, c on this one is 2, right? Because we went up 2 units to get to right there. And the formula is a squared minus b squared equals c squared. So that's going to be 9 minus b squared equals 4, 2 squared. Negative b squared equals negative 5. Or b squared equals 5. Or b equals radical 5. Do I need to know b equals radical 5, or do I just need to know what b squared is? I just need to know b squared, okay? So b squared is 5, and that right there is our answer, okay? Good? Okay, last one, and then we'll take a look at a couple of other examples that may be helpful on your assignment. Okay, so let's look at this one right here. Center is at 2, negative 3. You don't even need to read anything else, and you can get this far. X minus 2 quantity squared over something plus y plus 3 quantity squared over something equals 1. You ought to at least be able to get that far. Right? Okay. Now, I've got a graph right here because this is going to be helpful. A lot of times it's good to sketch these. So 2, negative 3 right there. There's the center. Focus is at 3, negative 3. And a vertex at 5, negative 3. Wouldn't that put a focus here and a vertex here? What letter should I use for this distance right here? A. And how far is that? 3. And what variable would I square that and put it underneath? The x, right? Because it's running in the x direction. So I'm going to put a 9 right here. I've put some dots on the page, and I've got most of the equation written down. Now I just need this. If this is 3, and that's 1, there's A. That's what C is. So I do a squared minus b squared equals c squared. Again, we take the big one, subtract what the small one would be so that it's inside. The foci have to be inside. So this is going to be 9 minus b squared equals 1 squared. So this is going to be b squared equals 8. So I put an 8 right there. End of story. Okay. Any questions? Okay, almost done. Let's take a quick look at this. Okay, this is an ellipse. You can tell because it's got two squared variables. They have the same sign but different coefficients. Technically, this has a coefficient of 1/25 and that has a coefficient of 1/9, right? Okay, what is this? How do you know? Same coefficient and same sign, right? Okay, watch. And then this would be a 1, right? Is that good? Still same sign, still same coefficient, still a circle, correct? Center is going to be 1, -1. How far should I go in the x direction? 5. How far should I go in the y direction? 5. Well, if you want 5 in each direction, what does that make this? Still makes it a circle. Okay? Does it have a major or minor axis? No. And guess what happens if you do a squared minus b squared equals c squared? Guess what you get? There's no big one or small one. They're both exactly the same size, so you get 0. So c squared equals 0. So if we tried to graph this like an ellipse, how far would we go from the center to get to the foci? 0. The foci are where? Right at the center. Okay? You can treat a circle just like you treat an ellipse. You get the same thing, except for the foci are smack dab on top of each other. Remember that string example that we looked at earlier? Okay? Imagine taking those 2 points and getting them closer and closer and closer together. Once they're right on top of each other, you're just taking a string and you're just going all the way around, right? Just like a circle. Okay? All right, there's the assignment in the textbook. There are some matching problems. Is there any way this one could be the answer to 1 or 2? Is there any way A could be the answer to 1 or 2? No way. Why not? Not centered at the origin. Take a look at this one. If it was going to be one of these two, which one does it have to be and why? It's got to be... Why? Because it has a longer major axis, runs vertical in the y direction. That means the bigger number has to be underneath there. Okay? I'm not saying that's what it is. You could mark it off and see if it works. Okay? Real quick. If they gave you something like this, could you come up with an equation? Center's pretty easy to find. If that's the major axis, you can figure out what A is, and if that's the minor axis, you can figure out what B is, right? Or, let's say they didn't give you a whole bunch of information, they just gave you 1 or 2 points or something like that. Maybe they gave you, you could figure out the center, you could figure out that, and then a point on the ellipse. Come up with as much as you can, and then plug in the point. Okay? This should be pretty simple, and so should those others. I do have this problem right here. Let's, here's what I want you to do. I want you to look up eccentricity and see if you can figure out how to tell what that is. Okay? Eccentricity. Okay? So look up eccentricity. Look up eccentricity of an ellipse. Okay? See what you find on that. Okay? Yes. Before you leave, turn in 10.2. Did you? 10.3 is due tomorrow. Are you going to do that? Okay. And then there's one other book floating out around there, so we need to make sure if that's you, make sure you bring it back. Thanks, Alexis.